Angle properties of circles. Property 3. Angles in the same segment are equal. Property number 3. Angles in the same segment of a circle are equal. Let's take a look at the following circle over here. Now we have learned from our first property, property number 1. Angle at the center is always twice the angle at the circumference. Correct? So now if we were to have this angle over here, recall that if we were to switch this position over to any side, anywhere along the circumference, okay, all the angles will still stay the same. That means this angle over here is the same as this angle ADB. But then it changes whenever it reaches to a different portion along this part of the circle. Why is that so? Now, angles in the same segment of the circle are equal. Taking a look at the point A and B, I have this to be a chord AB, then that will cut the circle into a major segment and a minor segment. So if I have the angles, as long as the angles are on the circumference within the same segment, in this case the major segment, all the angles over here will be equal. That gives us the property angles in same segment. Okay, now this picture can come in many different forms. Imagine we're to remove away the angle at center and the chord. I'll call it like the shape of a butterfly. So as long as I have 4 points, any 4 points on a circle, and they were to form something like a butterfly, a crisscross. Okay, now a butterfly have 2 wings, right? So the angles over here in the same segment will be same as this angle. The angle over here, this is also in the same segment, will be the same as this angle. And we have the vertically opposite angle. So these two are definitely the same angle. It can look in many different ways as long as I have 4 points on the circumference of our circle. So it does look like a little bit of a ribbon as well. Okay, and same thing, I will have this angle over here to be the same as this angle over here. Imagine the butterfly wings. So this one over here is the same as this. And then we have the vertically opposite angles. So these are just some representation of the angles in the same segment. And to me, they look like a butterfly, because butterfly have wings that are identical, exactly the same. Now let's apply this property to solve some of the questions. Please take out the following notes and worksheet. Now the worksheet over here does not have all the angle properties given, but instead just the question itself. But for me to highlight things to you, my convenience, I've decided to include all the 3 properties that we have learned. Property number 1, angle at the center is twice angle at the circumference. So I call this the Chinese dancer. And then angles in the same segment is 90 degree, property number 2. And then now we just learned our butterfly, angles in the same segment. Inside this diagram, AB is a diameter. Diameter, what will you think of a diameter? Which of the following 3 properties includes the one in the diameter? Well, angles in a semicircle are 90 degree. Let's try to see some of the interesting facts that we can see. So you see AB is now a semicircle at the diameter. Where is this angles in a semicircle 90 degrees? Oh well, do you see it over here? So actually I know that this is 90 degrees. Next one, they tell me I have APQ 35 degrees, ABR to be 22 degrees. Let's take a look at all the different properties that we have. Okay, other than the angle in the semicircle, do you see any Chinese dancer? Not at the moment. Do you see any butterfly? Not at the moment. Yes, I do see a butterfly. I saw this over here. You see the butterfly? So this is the angles in the same segment. Now let's see whether it'll be useful or not. Okay, the question says, now find angle ABQ. Oh, ABQ is over here. That means I will need to find this angle over here. What can I find? Oh, can you see the following triangle? PRB. It's a right angle triangle, right? We have 35 degrees, 90 degrees, 22. So in order to find the angle ABQ, we just need to do a simple subtraction. So let us begin with our angle properties. Number one, before we begin, angle ARB is 90 degrees. Why is that so? Because by property number 2, angles in the semicircle are 90 degrees. And then now I want to find angle ABQ. That gives me 180 degrees minus 90 degrees minus 35 and 22 to give me my answer 33 degrees. Do you know what's the reason for this property? The angle sum of triangle. Now number 2, QRA. Now I found my important information. This is 33 degrees and they want me to find angle QRA. Oh, do you see the butterfly? So according by the property number 3, angles in the same segment are equal. So therefore, angle QRA is 33 degrees. What's the reason? Angles in the same segment. Number 3. Find angle AOR. Have I drawn AOR in my diagram? So let us draw AOR in our diagram. AOR. O is the center of the circle. Is there any property that's related to center of the circle? Well, property number 1 says angle at the center is twice angle at the circumference. Can you identify the Chinese dancer? Now, the foot of the Chinese dancer is A and R, center O. So A and R must now go to the circumference. Where can we go to? Oh, I can see AR to B. Angle at the center, smiley face, is equals to twice angle at the circumference. So the angle at the circumference over here is the angle 22. So therefore, angle AOR will be 22 degrees times 2. Angle at center is 2 times angle at circumference. Have you gotten your answer? We'll move on to the next part and to explore more properties of the circle, and we'll come back to this worksheet a bit later.